In this video, we're going to look at the first part of the fundamental theorem of calculus. There is another part to this, but more of that when we look to compute integrals further down the line, when we've seen a little bit more. Not a complicated part of the theorem, we're just thinking right now. It's best to introduce this part. So we've talked about differentiation before. If we take the derivative of what we call an integral from a to x t t, and that is equal to f of x. And of course, if you haven't seen integration, this will look scary. The point here is, what we're saying is, if we're differentiating this function and we get this function back, albeit it's f of t and f of x, we're integrating this function f of t. When we integrate it and put x at this upper limit, it becomes a function of x, I guess. And a is just some constant. So, and then we're differentiating that again, and we get back to the function. So that shows that integration is the opposite of differentiation. We'll look more at the geometric interpretation. But this is part one of the fundamental theorem of calculus. Yeah, perhaps we'll discuss it more in detail, but now if we have a look at this f of t notation, I'll show you how this works. So if we take x of a of 3x squared, we'll do 3t squared dx. Now let's think about this. From this fundamental theorem of calculus, we know that if we differentiate the t integral, we get to 3 x squared. Okay, so this needs to integrate to something that is that would differentiate to that. So the way we do that is we think what's the opposite. When we differentiate power, we multiply down by this power, then reduce the power by 1. So what we'll do is we'll up the power by 1 and divide by the new power. So this will be equal to, and it turns out it's x cubed minus a cubed. And you know what? This is the second part of the fundamental theorem of calculus. We will just discuss this now. But first to compute this part, then if we differentiate that, remember it's the derivative of this here. A cubed is just a constant, so that just disappears. And this differentiates to 3x squared. So that's perfect. That's exactly what we wanted. The second part of the fundamental theorem of calculus is if we integrate from b to a some function f of x, then it's equal to big F of b minus big F of a. And f of b here, what f is a function that will differentiate to this, okay? So we'll look more at this, we'll look at, sometimes we can do integral functions and we don't need these limits, and we'll show you how to do those. We'll look at some standard results, we'll go back over how to integrate expressions like this and more complicated expressions. But the point of this introductory video to integration was to talk about, and then the main takeaway is that integration is the opposite of differentiation. And that's the start we need to take from this, and then when we've looked at integration a bit more, you can refer back to these fundamental theorems of calculus, the fundamental theorem of calculus in these two parts. If you're asked to reinstate it on the exam, you know that's what we call these two results. This one here and this one here. Okay, thank you very much for watching, and I hope to see you in the next video.